Welcome everybody. In this video, I'm going to go through building an assistant with the OpenAI API using the ChatGPT LLM Toolkit that we've built. So this has been kind of a long time coming. I've done a couple of preliminary videos where we've built some early integrations with the OpenAI Assistants API, just using API connector. This is going to go a bit deeper than those previous videos. I'm going to try to build an assistant that we're going to be using in just in our work. So for context, we are doing some work with user modeling using LLMs. So basically how you take user data and derive a model of your users' preferences, desires, behaviors, whatever, using LLMs as an intermediate piece of tech. So this is an old field that's been, well, it's an oldish field that's been around since early days of HCI, trying to understand how people interact with computers and how to model that behavior and pull out sort of psychological models, cognitive models of people interacting with software. And so this is my background actually in research. And so we are building a tool internally to go through some documents. There's a great GitHub repo that we're going to look at in a minute that has collected a whole bunch of these resources, PDFs from archive.org, which is a place where academic preprints or early versions of papers are hosted. It's very popular in machine learning to post your papers here when you first finish them prior to sort of peer-reviewed journal publications, and sometimes they stay on archive. But in any case, there's lots of stuff on archive.org that we can look at. And so this GitHub repo has collected these PDFs. So what we're going to do is build an assistant that we're going to feed these. I think it's about 400 documents, if I recall correctly. We're going to try to feed these 400 PDFs to our assistant so that we can start to do some of the research that we want to do. So this process will be kind of rough. I have a few things to do in advance of actually building the assistant. So right now I've got the editor for the demo page or the documentation page for this plugin, this LLM Toolkit plugin. And I'm updating this in preparation for this video, going in to kind of explain how to use assistants with the plugin. So this is what the page currently looks like. We have an assistants tab down here, but no wrapper for it. And so I want to do two things. I want to create a wrapper in Bubble, which you can skip over if this is basic beginner stuff for you. And then I want to stick a link to our documentation that we have currently here on Notion. This will just be the temporary sort of embedding of this documentation, which has to be updated, but we'll also have a video here. So take this over. So I'm just going to quickly spin up a container here and populate that. I'm just taking one of my previous wrappers and pasting it into this parent wrapper. And then here, I'll just change the name. And I'll delete all of the children. I'll add a text element. And then we'll say video coming soon here. Okay, so that's just kind of a stub for these docs. And I forgot to change the conditional here. The way that I handle this navigation is I just have a state on the page called current section, and it's set to an option set of different options here. And assistance is when we want to show this container. So, okay, so that's done. The next thing I want to do is open up that GitHub repo and show you what I'm talking about with these resources. And so that's here. So it's Tem maybe, I'm not sure. And LLM-UM-reading is the name. So large language models for user modeling, reading list. And so you can see this repository is basically the reference list from their paper here, which is also on archive. So I'm going to shrink this down now that we're doing stuff. And so this has some of the same preamble that I mentioned earlier about sort of figuring out profiles and preferences and so forth. And so we'll see in the repo, there's a lot of links to these archive PDFs. So you click here, you'll get the actual paper. And we're going to, I think, basically be getting a bunch of these PDFs from this repo and then somehow downloading those. And so I don't know at this point whether we can feed a list of URLs directly to the Assistants API as the files. I think we probably can, but if we can't, then we have to find some other strategy where we download all the PDFs and then pass them up. And just as a note, we're going to do this using the Assistants API and the plugin, but there are a couple of other ways you could do this. So in some cases, you might not want to use assistants. You might want to use just a retrieval augmented generation system or a RAG app, where you do all of the document uploading and parsing and chunking and so forth that assistants normally handles. Just because there's some additional overhead and cost with assistants that in some cases you might not want. So we'll be looking at that as an alternative option in a different tutorial. And if we reach a scenario in this tutorial where we can't upload URLs to the API, one possibility might be building a sort of bulk upload feature for the plugin. So you upload like a zip file maybe, or maybe you upload a list of URLs or something, and the plugin will handle that process. If it's not natively supported, that might be something useful. So I'll think about, I'll keep, that's running in the back of my mind in case we run into a scenario that we need it. But anyway, for now, let's look at this and figure out how we would get the PDFs. So it looks like here there's a bunch of links and they point to, it's hard to see probably. If I make this bigger, it doesn't change anything. But down in the bottom left, there's a archive.org/ABS and then a document ID. Right, so if we click one of these, we'll get one of these PDFs that we looked at before. So basically what we want to do is get all these links into our assistant. So if we open up the assistant's documentation, we want to look at probably creating assistants, maybe managing threads, definitely file search. So this is one of the tools that the assistants can take. So the tools parameter, you want to create a new assistant with file search enabled. Okay, and so so this goes into the tools array, which we'll look at when we're actually building our page. We'll basically copy this text probably as for that tools field. And then here, the next thing to know about is the vector store. So if you haven't done this before, a vector store is like a database for vector encoded data. So the store is just like a storehouse or a place to put it, right? But a vector is like a long string of numbers that represents the meaning of some chunk of text in a high dimensional semantic space. So the basic idea here is you can take a chunk of text and you can encode it into numbers, and then you can find out how close two chunks of text are by using those numbers. And so that's what these vector stores do, is they hold those numeric representations of chunks of text. So here, they're using the Python client here to create a vector store named financial statements. And then they're passing file paths. These are local file paths. So it looks like they're, I guess, concatenating these two files as a stream. And then here they are uploading and polling. So they're uploading the files, adding them to the vector store, and polling the status of the file batch for completion. So this is one way of getting your files to an assistant. So here they're doing this in two different stages. They're creating their assistant and then creating the vector store and uploading the files. I think you may be able to do this in one step, but we'll follow the same pattern when we're using the plugin. We're not likely to be using the Python client if we're interacting with code on the back end, maybe if we're doing some sort of bulk upload feature in the plugin. But if we can pass URLs here, then, or maybe it would be here. Let's see. If we go to the actual API reference page, we can probably see what is an allowable input to these parameters, like the file paths here. So, oh, this is kind of handy. If you click API reference here, it actually takes you to the section that you're in the documentation, which is quite nice, sensible. So here, let's go to vector stores. So here in the documentation for vector store, for this method, creating a vector store, you can see that we can pass file IDs optionally when we create it. These IDs point to files that have already been uploaded to the file API. So you'd want to come here to files and look at uploading files. So this is a little confusing, I think. So vector stores and then vector store files. You might think that this is like the file object, but this is sort of in between. You've got the file API and the vector store API, and the vector store file is linking a vector store to a specific file. So this is the ability of that vector store to access that file. So you could have the same file in multiple vector stores. I'm not certain why this is split up from files, like why we need to have vector store files in addition to files. Maybe it's related to using different chunking strategies in different vector stores, possibly. Not sure. But in any case, what we want to do is under files, we want to see if we can upload. So not file name. So it says file object. So this suggests to me that we cannot pass a URL. So what we can do, just to be sure, is check this assistant tools guide. Maybe there's something in here about using URLs, but okay, so it seems like we do need the file object. So we'll have to think about the best way to do that in a minute once we've got the links to the PDFs. I have a couple of ideas, but something that might be interesting reading is if you go to the docs for assistants and go to the file search quick start, there's a cool section down here that explains what actually happens when you use the file search with assistants. And so this kind of, in my mind, justifies some of the additional overhead cost that we were talking about before. So it tells you, first of all, it implements some retrieval best practices out of the box. So like how large the chunk size should be, what the overlap should be, for example, is here. You can change these. This embedding model, text embedding 3 large, and then the maximum number of chunks that are pulled from the vector stores and attached to your message. Then we've got some limitations. So deterministic pre-search filtering, that's interesting, is sort of paring down the data that comes back. Parsing images within documents. This is something we were just talking about yesterday with a client. This is an interesting issue if you have charts or illustrations or graphs, tables that have been rendered as images and so forth. There can be interesting information in there that GPT-4o sometimes can use. How reliable that is in the context of different apps and assistants and so forth is unclear. And then retrieval over structured file formats like CSV sometimes doesn't always work the best. And then summarization. And this is kind of an interesting one. You might think you want to summarize like a large corpus of text or a whole body of documents. And so you stick a bunch in there and ask for a summary. But this is part of that same conversation we had yesterday is the tool. If you want, we were looking at very large documents on the order of hundreds of pages. And if you want to pull out, say, all of the headings from that document to get a skeleton of the content, let's say, it's better if you can put all of that into the prompt and pull it out. If you chunk the whole document up, it loses that coherence and that sense of order, which can be really important for certain applications. And so in that context, assistants might not be quite what you're looking for if you're doing large document semantic search. It really depends on your use case, which is why we'll look at that RAG approach later, the retrieval augmented generation. Anyway, that's a bit of a tangent. I want to go back now to the GitHub repo and think about how we could get the PDF links. So one thing we could do is if we copy this, I don't believe we will get the link. No, we get the rendered markdown. So there's a couple of options. We could, view page source would probably give us the PDFs. This is kind of not the best way, but we have this href of this PDF. I think we could probably take this source and get all the PDFs that way. We could probably dump this into ChatGPT even and say extract all the PDFs. That may or may not work. So if we look at some of these links, they don't actually have PDF in the link. If we go to the page and then click on the PDF, it's there. But it's not here on the GitHub page, so it won't show. So we could alternatively look for, in the source, we could look for archive. Get all the references to archive. We can see here there's 508 matches. So another thing we could do is open the file, and we could probably look at this so we could look at it raw. And here, the links will be just rendered. So what we could do is like extract all of these, this pattern, like using a regex or an LLM or something. This would fit into ChatGPT, I think. So let's do that. We'll take this text, we'll go to ChatGPT, and we'll just say, please extract all the archive links in a list. Please extract all links to Okay, so it's now extracting the list of links. We should be able to click on them and actually see this is good. This is the author's paper, I believe. And then we can click these ones. Hopefully these are all sensible. So far, so good. So once these are all printed out, then we have a decision to make, which is, do we write a loop locally that just downloads all these files? Do we find some other way to upload these URLs? We should probably test. I don't think it's going to work, but we should probably test creating a dummy vector store and sending, trying to upload to the file API, just using a URL just to see if it's an undocumented but supported feature. It seems unlikely to me that they would do that because it's probably quite helpful to have that ability. So if that doesn't work, I'll have to decide whether to just do this locally and then loop through them using that Python client. That doesn't seem like the most user-friendly way of doing it. But if that's the case, if there isn't an easier way, then that's a good reason to maybe build something. So we ran out of output here, output context, and it's continuing. If this is all working as it's intended, this is pretty impressive, I think. Being able to continue amazes me still. It didn't used to work very well, or rather, it didn't work very well in the former iterations of GPT. But now I'll say this is probably not a good justifiable use of an LLM, especially sort of a flagship one, because you could easily do this kind of extraction with some simple regex expression. Like a regular expression is just a little bit of code that tells the program to look for some repeating pattern. And it looks like this repeats for basically every link except this one. So what we could have done instead is ask GPT-4 to write us that code and then run the code. But this was a bit easier, so we did this. So anyway, let's take, how many links do we have here? Okay, so I'm going to take these links that we extracted, paste them over here. Just make a note here, so links to PDFs, and stick them in here. I would kind of like to know how many I have here. So what I will do, I think, is delete this. And actually, let's just do this. If we paste this into a text file, and then if we cat that file to something called WC, we can see we have 237 links, or 237 lines in this file, which means 237 links. So that's fewer papers than I thought, but it's still quite a lot. Just to be on the safe side, I will just double check with ChatGPT. Yeah, were there links that weren't archived? In case there are papers elsewhere. So we got a bunch of other ones, 10 or so here, that we could stick in our notebook. The problem with these ones probably is that they might not be openly available. Archive, they're free to get, but let's say other links. This one would be, don't recognize this. So we could check each of these in turn, but I think I might do that in my own time, so to speak. I'm going to focus on these archive links for this demo, just because we know the links will resolve to PDFs and we'll be okay. Now, something worth noting here is that there are two kinds of links in this list. This is just sort of nitty-gritty data science stuff in case this is interesting to you. There's the link structure is basically root domain of archive.org, and then it's either ABS, which I believe is for abstract, or PDF. But the number remains the same, I think, in both cases. So I think in all of these cases where we have ABS instead of PDF, we want to switch this to PDF, and then we want to append PDF on the end. So there's a few ways that we could do that. I think I can do a find and replace with VS Code or with Vim, I think is what I'll use. So let's do that again. If we just paste, whoops. So here's the same file. If we say replace all instances of ABS with PDF, that's one thing. And then we just need to add PDF on the end of all the lines that don't have PDF. So we can record a macro or a sequence of commands. Like you can do this in Excel and Emacs and Vim and stuff. But so what I'm going to do here is record a sequence of keystrokes where I append PDF to the end. And then I can just repeat that sequence. And so this is a little bit tedious, but I just basically mash the @ key and get these filled in. I can also, if you're interested, you can do like 10 at a time. So if you have a big chunk, you can just fill them all in. So what I could do actually here is fill them all in and then just delete the ones that have 2. So this one, and actually we could find that by searching for that pattern. So just deleting each of these instances. Like I said, it's not the most elegant solution, but it's fairly quick, low effort, low cognition. Okay, so now we have all of our links in that format now. So we should now be able to feed this to a loop and download all the files. Okay, so now let's think about what we would do. We've got this list of PDFs. One simple thing, of course, is we could come to ChatGPT and say, write me a simple Python function that downloads these files. And you might say, downloads a list of files that are in a text file, one link per file. So if we say this, it'll write us, a 4-line function or something, probably using requests. Yeah. And so basically we just read in the file, loop through each line. So this read lines function will take a text file or a CSV file or something and read each line of it. And so it's saying each, the URLs is each new line, basically. We're saying for each one, strip any white space, which is a nice hygiene thing. And then we're going to create a file name. So we're going to take the last piece of the path of the URL and set that to the file name. We'll grab it, raise an exception if there's a problem with the download. Otherwise, we'll write it out locally at the same file name as the link. And then we'll say we downloaded it. And so basically, if we copy this into a Python file, I'll just do this for, for an exercise. We might need it anyway. So let's do this. First, I'm going to open up Tmux. Tmux is this shell program to let you have multiple windows and navigate around. So I'm going to go here to tutorials. I already have a directory here called Assistants Part 3. So we've got some, these are the video files. So let's say make a directory for code, and we'll make a file called, I don't know, download files.py, and we'll put that code in here. We'll have to install requests, I think, and then whatever the file name is. So what we can do here is we can move that links file. So it's right here. And we can say links.txt. Our download directory will be downloads. And so this one here, this line here rather, will create that directory in here, downloads, and then it'll download each file. So this will probably take a couple minutes. It'd be nice to have these files anyway for myself. So I'll run this now. I think I need Python 3 and then download files. And yeah, it looks like request is installed in a sort of base environment. So it's just downloading each of these PDFs. So this is fine, right? This will get the files onto your computer. Whoops. So like we can open up one of these PDFs just to see what's inside these things. Because the directory is updating a whole bunch. This is not the most stable view here, but we could open this with a different file or a different program rather. So so this is good. We're sort of building our library internally. This might also be nice to feed this to Zotero or something if you do research. This is a good way, to do a lit review, or to start off a lit review maybe if you're into research. So from here, we still have a challenge, which is how do we get all of these files to the File API? So we can upload them all. We can write a snippet of code from using the OpenAI SDK. And once we have uploaded all those files to the File API, we then have to link them to a vector store, or we can create a vector store with those files. So if we use this API call, vectorstores.create, and we pass it some file IDs that we got from that running that loop, then this will work fine, right? So we could write a little loop that returns a list of all the file IDs that we just uploaded and store that somewhere. And then when we create a new vector store, we pass in this list of file IDs. Then we have that vector store ready for our assistant that we can attach to it. But it's kind of cumbersome. It requires you to write some code and manage things like keeping that list of file IDs in memory. Or, you could spit it out to a file, I suppose is probably safer. You can always go back and use like the list file IDs call to get the list of files that you have in the API. But in any case, it's not the most seamless thing. So what I'm going to do before building anything custom is I'm just going to do a web search and see if there's a better way to do this that I'm missing, in case there's something out there. Okay, I can't find anything on the web about uploading URLs. So like a list of URLs to bulk upload files. I want to have this capability, so I think I'm going to build it as part of the plugins feature set. But in order to get through the first pass of the assistant setup, I think I'm going to skip that for now, and I'll put that in a different video where we build out that feature. And for right now, what I'll do is I'll just take the code snippet from their documentation to loop over the list of files that I've just downloaded locally. These files that we're downloading over here, they should be done now, I think. So I got blocked or throttled, actually. I think this 403 error, at some point, the archive server started blocking the requests. So the first 100 or so downloaded, and then from there on out, they were forbidden. So this introduces a little bit of a problem. What I can do is duplicate the list of links and remove all the ones from the top that we've already downloaded and then download the rest. But I need to check their terms of service now to see if this rate limiting is like per hour, per day, forever. So I'll look at that now. Okay, so there's a page here, bulk access overview on archive. They do support bulk access, bulk data access through their API. This is probably sort of the more, if you want to do this at scale, probably the right way to do this. So in archives, robot.txt file, they do allow robots to scrape /PDF. So I think we're not violating the terms of service. So I think for simplicity, I'm just going to take the top 100 or so off the links, the URLs that we already have, and then grab the other ones. So we can scroll up here and see that the download stopped at 2303.02148. So if we copy links to links backup, and we look for this one, delete all the ones above it. Okay, so there's a mismatch between what failed to download and what was in the links file. So I'm just going to take this text and create a new list of files for a second pass. And I'll add some delay so that we don't run into this issue again. So for reference, I'm making my terminal text super small so that I can select all of it, and then I'm going to dump it into Vim and edit it again. We'll paste it in here, and then basically we just want to strip off all this text here. Right. So we can issue a Vim command, which is delete to the second H. So the command is D2TH. Doesn't matter if you're not using Vim, but then we can just quickly strip off all of the extra sort of text. And we can turn this into a macro again. And we can say, do it to all of them. And then we're done. And so now we should be able to run that same code. So we'll move denied links up a level. And we'll reopen download files. And the file here now will be denied links. And then here, I'm just going to add a 3-second delay in between each of the downloads. So if this works, then we should be able to get the rest of our files. So we will do this again. Oh, and I missed a line here at the beginning. So we'll do that again. Okay, and so now it takes 3 seconds for the first one to start. And hopefully spacing them out like this will not violate the, the rate limit. I think this is okay. So this will take about 5 minutes and I'll come back when this is done. Okay, so all of these have been downloaded. I'm back from lunch. The next thing we're going to do is to create the assistant, create the vector store, and then upload a couple of files using all of that using the plugin, just kind of to see how to get things started. And then what I'll probably do is come back to this folder, take a snippet of code, and just loop through all these files to upload them to the File API, rather than doing that manually for 200 and some files. It'll take forever. And like I said earlier, I'll probably build a feature to make this easier in the plugin, but I'm not sure yet how we're going to do that. Okay, so first thing we'll do is we'll come to Bubble. So we have this demo app. So this app, you can inspect the workflows. This app effectively serves as the documentation for the plugin. And some of these pages, some of them are useful to look at, some of them are not. Here's the index page, or sorry, this is the earlier assistance demo. Let's close this. Here's the index page. So this is kind of the landing page for the plugin where you can test it. So what we're going to be doing is building a page on here. So from here, you can go to the tutorials page, and this is where this video will be hosted for a little bit longer before we migrate to the Academy, which should be launching soon, but that's another project. So here's the link that we put in at the beginning of this video to this Notion document, and then this video will be put here. So in this app, you have access to, if you come over to this assistant demo page, this sort of walks you through the steps of creating an assistant and creating a thread and a run with that assistant. This is just pretty sort of slapped together at the moment. But it sort of illustrates the workflows if you want to do step by step to sort of see the process here. And it kind of lays out, you create the assistant, you create the thread, then you create a run. But this doesn't have a whole lot of complexity built into it. There's no file search or file upload. There's not a multi-turn conversational interface to be able to interact with the thing. So there's lots more to do on top of this. And so the assistant that I build out now is going to have some of those features. Okay, so let's start walking through the process of creating this assistant. So I'm going to do this bit from scratch, just on kind of a scratch pad. I'm going to be rebuilding it effectively in our main app. So we'll say assistant, scratch pad. We'll just clone this page here and delete some stuff. Okay, so the first thing we're going to want to do is to create the assistant. So we're just going to set up that first call. So note that we have an assistance container on here already. If we delete this, which we might as well, under visual elements in your Bubble editor, there's this assistance container object. So you can put that on the page. You can make it small. It doesn't have to be really visible. Put it at the end of the page. You can make it 1 pixel by 1 pixel if you want, but it doesn't show up on the page. So now I'm just going to have a button here to create, and we'll fill in the workflow manually. You can add dynamic fields to all of this through inputs and drop downs and things like that. But we're not going to do that for this interface, for this part yet, because this is just to get us going. So we want to create an assistant with this action. This can stay the same, content type in OpenAI beta. The model that we'll use is GPT-4o, the latest and greatest from OpenAI. We'll give it a name, user modeling with LLMs. We could give it a description here. This is mostly for internal purposes. And what will change here is the tools. We'll give it file search. And then we'll have another workflow to create the vector store and stuff. So if we run this as it is, it'll fail because we don't have an authorization header. So what we can do is we can go to our OpenAI dashboard and get an API key. So here in the project-based views, the new view for API keys, you can click Create New Secret Key and give it a name. So we just call this Demo 1 and create it. Now, one way that we can bring this in is we can copy it here and paste it in the workflow. So this needs to be better documented, but this authorization header actually has to begin with bearer like this, and this will work. So this is one way to do this. Now, if you run it like this, you'll create your assistant on the page, sort of on an on-page workflow. So we click step by step, click create. We can see the workflow. Unfortunately, this exposes our API key, right? We don't want that. So if we click run next, we'll get our assistant. So I can show you this by opening up the dashboard for assistants. So over here in the playground, we've got assistants, and here's the one that we just created, user modeling with LLMs. Note that these assistants, along with the API keys, are scoped to a project. So it's quite handy if you want to try out different assistants and different strategies and things. You can, organize those by different projects as well. Okay, so the point is here we have this LLM that we created, which is good, but probably we don't want to do this in this way because it exposes our API key, right? So if the user provides their own API key, that's fine. If they're going to see their own API key, that's not a big deal. But what is more likely you're going to want to do is to protect that API key. And there's a couple ways you can do that. So one way is you can leave this blank because this basically overrides what's in the plugin settings. So you can come to the plugin tab, and where it says authorization shared headers, and then this one for development, that's the same header. It's the authorization header, but it's stored sort of at the level of the plugin. So rather than in the workflow. So if you put that in here, now if we rerun that, we'll get another, hopefully we'll get another assistant. You can see here there's no authorization header, right? So you can't see it in the bubble inspector. Let's see if we can see it in the network. So I'm going to run this again with the network tab open to see if the network request. And so digging around in the network requests and responses also doesn't reveal the API key, as far as I can discern. If you happen to know a vulnerability here or a way of retrieving this API key through this particular setup, please let me know. Please reach out to us because we don't want that to be a possible exploit for people to get attacked with. So do the right thing if you know. Okay, so another option you have, though, is you can create a backend workflow. And in this case, what you'll do is you'll trigger the workflow from the front end, but the API key won't be in that. So here we'll say we'll create a new API workflow called create assistant backend. Doesn't need to be public. And then here we can set up whatever parameters we need. So for example, first what we'll do is we'll add our action here, create assistant. And you can figure out from here what kind of parameters you might want to pass. So model, let's just say we want to pass the model or the name. The name is more likely to change. So let's say in terms of between different tests of the model. So we'll say the name gets passed into this field here. So that's this argument. Here we'll just make this static at GPT 4.0 rather. Yeah, and then in here we can put our API key. Because when we run it from here, by triggering a backend workflow, so instead of running this action directly, we say schedule API workflow, and then we pick create assistant backend. We give it a name. So like, you put an input box here and read the value of that, for example. So the name will be whatever the input value is. And then here, just current date time. Now, when you run this, you can't inspect and see the API key. It's just stored in the backend, right? So in the serverless function in the backend. So those are three different ways you can set that up. Now, I'm not going to do that for all of the additional workflows that we use, but the same pattern applies to most of them, except for the front end streaming stuff, which we'll look at in a little bit when we get there. And so now just to demonstrate this last one, let's say test 3. When we run it, we just see this. We don't see the API key, right? And there is our assistant that we will delete. Now we have an assistant, but we don't have file search enabled, we can see. So what we could do is change our assistant. We could run the change assistant action, or we could create a new assistant that has file search enabled. I'm going to recreate this one with file search, but the pattern, the same basic argument will be fed in both cases. So I'll show you here. If we create an assistant, currently we have it wired up in the back end. We'll say the tools here, we want to paste that file search syntax. And we can get that from the docs right here. So if we send this string, this array really, as our tools argument, then when we create this assistant, file search will be turned on. So right now we have no file search, but if we rerun this now, I can close that. So we'll create our new assistant, and we should be able to select it momentarily. And so this is the new one. We can see file search is enabled. We actually have several with this name. So we're going to delete all these other ones. Okay, so now we can see we have file search enabled. So we can add a file here manually, right? So if you click to upload and just upload a file, it'll create the vector store for you. If you pick select a vector store and you already have one, you can pick it here, right? So, there's different ways that we can create a vector store. Here we don't have any, right? So let's create one through the plugin. So let's create a different button. So this will be create assistant. Then we'll have another button that is create vector store. And we will add a workflow, which is create vector store. So it turns out create vector store isn't included in the plugin. I guess we missed that API integration, which is not good, but is an opportunity to teach you how you might do this in your own plugins. So I'll bring up the LLM Toolkit plugin and we'll add this API call in. So what I wanted this button to do is create a vector store. It's not currently part of the plugin. So what we're going to do is create an action that's called create vector store, which will be a preliminary action here before we can start adding files. So I'm going to open up the plugin editor for the LLM Toolkit plugin, and we'll look at adding that API connection. Note that you can also add this in API connector. You could do it in here, but I need to do it for the plugin, so I'll do it. It's effectively the same interface. So you could say here, call your AI, your API, say OpenAI, and you add a call here, which would be like create vector store, right? All of this we're just going to do in the plugin, and it's identical. So let's delete this. Okay, so this is the plugin editor loading. This particular action can be done very easily with an API call. So if we come into API calls, we have all these actions here, right? A whole bunch of different API calls. Okay, so I figured out what was wrong. We do have this action create vector store here, but it's configured to be a data API call, which means you load it as the data source of a repeating group or a text element or something. And it doesn't expose it as an action in the workflow editor. But this is a mistake, I think, that I think we just did this by mistake. So I'm going to change this to an action and publish this update. And then if I update the plugin in that app, the demo app, this will be available as an action. So I'll do that now, actually. And it takes a couple minutes before the plugin registry updates, before I'll be able to update it in the app. So I'll walk through these fields and the setup after I've reinitialized and updated the plugin. Okay, so here's the reinitialized response, and then I'll publish it. You can basically reproduce this by coming to the API reference, finding the action that you want to use. So create vector stores, the API call here. Select curl and click copy, and then you can go into your API connector or your bubble plugin, and down at the bottom, there's import another call from curl. If you do this, you now have a new action. This is create vector store that we just imported. I'm going to delete this in a minute, but you can see it sets the method, it sets it as uses data, which is probably where our trouble came from. We set it to action. It sets your headers here, and then it sets up the body down here. So it basically fills in everything for you, which is great. So in any case, we're going to delete this. We have some modifications to our action here, where we have file IDs, name, expires after, these optional parameters that you don't have to send. And so these are just nice to have in here if you want to use them. Okay, so the plugin registry for Bubble still hasn't updated. I refreshed the page and we can't update the plugin yet to get this new changed feature. So in the meantime, I'm going to get the code to upload files to the vector store in a loop. We'll do it through the plugin to show how it works, but then I'm going to just do this with a script in the back end for the rest of the PDFs. Here we have our code again. Probably just going to write a little script to upload a list of files from a directory. So we have this downloads directory, which is full of PDFs. So we basically want to take all these file paths and upload them to the File API. So if we come over to the OpenAI reference, if we come back to Files and upload a file, one way we can do it is through curl again. So we can, this is the action that we'll use in the plugin, basically, is to upload a file through an API endpoint like this. But if you're using Python, which we can do, then we can write a simple little loop like this. So, and then we'll get the structure of a file object back with an ID, size, created, file name, purpose. So this is fairly simple. We could write this line. For the sake of the script, though, it requires us to install this package. And so to do this, we'd create a virtual environment with Python, install the package, and then use it in the script, and that would be fine. But this might be a little bit simpler if we just use requests and post to this endpoint. I suspect it's a post. And so, yeah, it's just attaching the file body, file object as a body here. So either of these would work. I'm not sure which one is more or less difficult to implement. They're both pretty straightforward. I think I'll do the API version, the SDK version rather, just to show how it might be done, because it's might not be obvious if you're not used to doing this. So let's do this. Okay, so we have another shell in our terminal here. And so what we're going to do is create what's called a virtual environment. And so this is like an isolated instance of Python with dependencies installed, like modules. And so what we can do, the syntax can be a little bit different depending on what operating system you're on, but it's pretty straightforward. What you can do after that is you can like activate this virtual environment, and now we can install this package, OpenAI. Whoops. So we'll say pip install OpenAI. If we do this without using a virtual environment, it will install it to our system-wide Python installation, which can cause issues. It's kind of a pain. But you can see it's pretty simple, right? Once you create the virtual environment, turn it on, you just run pip install, and now it's available. So now we can take this code, and normally I would just open Vim and say upload file or file create or something. Create file OpenAI maybe, and paste it in. So I'll bring VS Code over now and use that a little bit because I realize Vim is not the most common text editor. A lot more people are using VS Code, so let's use that for the sake of consistency. All right, so here's our directory in VS Code. And so here's our create file OpenAI script. We could open up a terminal and run this. You can see our virtual environment is nicely activated for us, which is great. We could say Python, and then we could run this file. Now we're passing in a file name that doesn't exist, right? So what we want to do basically is convert this to a script that says take all the file paths in a particular directory, which is this downloads directory, and run it. So like run a loop over all files in .downloads and upload them to the OpenAI API. So this is Copilot auto-completing. So we can let Copilot just basically auto-create a script for us. You can do this in ChatGPT as well. There's some plugins for VS Code that will do this with sort of bigger windows. Like Genie, I think, is one. So we have our comment here. So we could say, there's different ways that we could do this. You could do it in a for loop. So it says for every file in list this directory. We're going to use this method here, and then it will just spit out what we uploaded. So we could try this, can delete this. So I'm going to make some space here. Now we need to import OS, operating system interaction. And one thing I would do here for testing is I would do a subset of this directory, like maybe the first couple of items, first 3 items, just to see that things are working. And also you don't want to necessarily upload them all in the first shot. One thing we'll realize is it's going to upload the file. It's going to print out that it uploaded the file, but then we don't have it in a list. So what we should probably do is say, and keep all file IDs in a list that gets written to a file, something like this. And so then here we probably want to say, yeah, so basically this just gets duplicated again. And so this should do, I think, what we want. If we make this a little bit bigger again. So first we open this file, to create this file called fileids.txt in writable mode, call it F. And then for each file in this directory, we're going to use the OpenAI SDK to create a file object. Purpose here should be assistants. And it'll say, here's the file ID for this particular upload, and it's going to write it to that fileids.txt. And this with syntax, if you're new to Python, this just means that this file will be closed after the operation is done. It's called the context manager. Okay, so if we save this, and now if we run this, oh, it's giving us an error that the OpenAI client key needs to be set, or we can set it in the OpenAI API key environment variable. So either of those could be fine. For now, let's just code it here. And so we'll put our API key in there. I'm not sure if the syntax is this or not, but we will find out shortly if it doesn't work. So we'll copy that, paste it here. And we'll try to run this again. So this appears to be failing. Client.files.create, and then response doesn't appear to be something that can be indexed into. So we could say print the response and print the type of response just while we're debugging. Just do this. Okay, so there's a file object with a file name, status, and details. Yeah, so because it's an object that's returned, this file object class from this package, we can just dot notation into it. So response.id instead of the dictionary indexing with square brackets. So here's what we uploaded. So now if we come back to our dashboard or playground, we can see under storage, these are the files that we just uploaded. And this is that vector store that we created when we initialized that API call. Now you can see we have duplicates of these files, right? Because we did this twice. Okay, so that worked through the back end. Let's come back to our plugin to see if the vector store, create vector store action is now available. We'll clear out those files before we upload the full directory so we don't have duplicates. But now let's just create the vector store that we actually want to use. Okay, so now it's ready to upgrade. Now, something worth thinking about is you have an option of uploading all your files, keeping those file IDs, and then creating a vector store that has those file IDs on creation. That's one way to do it. So that's this approach here so far. We have these file IDs, and we can pass these in as when we create our vector store. So in vector stores, when we create one, we can pass a list of file IDs. So in our action over here, if we have some way of uploading all those files and keeping those file IDs, then when we run this action, create vector store, we can pass in the file IDs here. So we can pass in an array and include those file IDs that we just saw over here, these 3, right? So if we wanted to do that, if we had it, say for example, we had a loop set up in our bubble database that uploads the files recursively, or a list of files or something, and each time it does it, it gets a file ID back and then stores that in a list somewhere, then you would put those in here. So if we took these file IDs here and put them in here, you'd have to wrap them in quotes and commas, but that's fairly easy to do with format as text or one of those other operators. Okay, so here we're going to test this. We've got these 3 files uploaded, so let's test these just as a dummy. And just a usability note, I know these little boxes are not easy to work with if you're trying to enter a long block of text like this. So I often have like a notepad that I'll take my text, or it could be in VS Code if you're coding, just somewhere to put like raw text. And then you can paste it in here, and it's a lot easier to interact with, right? So you can, copy, paste, modify, add quotes and stuff in a text editor, and then copy it from here and paste it back in here. It's way easier than trying to like navigate around with only being able to see, 30 characters at a time. So just a note. Okay, so now we're going to create this vector store, and we'll call it test1. And so that should populate a new vector store over in our playground once we go back to it. So let's test that now. If we click create vector store, we get an error. So it's giving us an error about our invalid body. So let's inspect our workflow. And I can see here, here's a good example of what I was talking about. One of these files doesn't have closing quotes, so the string wasn't valid. So if we repaste it in there, now we can see, maybe you can see that it's there. Let's try again. Okay, now we're getting a different error, which is that files with extensions .02157 are not supported for retrieval. So this is interesting. The files themselves should have PDF on the end. So what happened, I think, is in our upload script, it's pulling off the extension, it appears. So this is not good. So let's try this. If we come back to our files, we can see that 2 of these don't have extensions for some reason. So I'm going to look at the files in the directory to see what's going on here. Okay, and we can see there's this file here and this file here that don't have PDF on the end. So maybe I just accidentally removed it. So I'm going to see if I can open these. That's a PDF and that's a PDF. So I think I just made a mistake here. So I'm going to move that to 2307. And note that we actually have 2 versions of this, I think. So this is even a little bit more confusing. So there is one of these already with PDF on the end of it. And I suspect that will be true of this one as well. Yeah. So those are just hangers on for some reason. So we can just remove those. And now just deleting them from here, we can probably just keep the other ones for right now. We'll delete them later. But this does sort of mix up our file ID thing. What we could do is just grab the files from here. You click on it and it copies it, so that's kind of handy. So maybe what I'll do is I'll get rid of this duplicate and this one, and then I'll just manually replace the file IDs for these ones. So we can even do this. This might be a bit easier. All right, so that's GS7, and then this one is this. Okay, so those have been swapped. So now if we try to create a vector store with those file IDs, hopefully things will work. So let's try again. And no errors. Usually that's a good sign. So if we come back to storage and vector stores, here we go, test1 313. That is the current time. This was the failed one. I guess it had 2 of the files, or no, it didn't work. But let's just delete these tests here. So we have this vector store and it has some files in it. These 3 PDFs. It's not currently used by any of our assistants. If you click this button, you'll get just an untitled assistant. It will create one that you can then modify, and that's fine. But we'd prefer to have it on this assistant here. So we'll delete this one. So the UI doesn't seem to allow you to select the assistant that you want to add here if it's not a new one. Or maybe I'm missing something. But if we take the vector store ID, which is this, we come to our assistants, and in here, we say select vector store. So we click add files, select vector store, and put the vector store ID in here. When we select that, now it will have access to those documents. And so now that's effectively what you need to do to get some files to one of your assistants, right? Create a vector store, add some files to it, and then attach it to your assistant. And there's a few different ways you can do that based on whether you're doing it at the beginning or later on in the life cycle of the assistant. But now, why don't we see if this is actually working? So hopefully we should be able to say, tell me about user modeling and cite your research, cite your sources. If we say something like this, hopefully it will go into our documents that we've uploaded and reference them. This is what we would hope, right? So for example, we've got a couple of references here. They're all being spit out at the end as well. So you see, this is quite surprisingly good. So it gives us kind of an introduction. User modeling with large language models focuses on improving the way conversational recommender systems interact with users. So this is not exactly the way I would conceptualize this, but this is interesting. Conversational recommender systems, I think, is one subset of software that could benefit from doing this kind of user modeling. But that's not critical here. This is just a test, right? We don't have all the documents yet. But if we come down here and hover over these links, it links us to the file name, or it shows us the file name rather, of the reference. And so if we were to look at the logs, I suspect that if we dig into the actual messages that are being sent over, we can find the paths or the locations of these files and retrieve them as well, which sometimes might be helpful. Maybe just having the file ID is enough, and you do it internally. Like with your own system, you can reference your files. So here, for example, this is not the easiest system to sort of dig into. I don't know if there's an expand all, but there's, you can see here, I think there were 480 steps in this run. So that's, it's kind of an overwhelming amount of data if you're not sure where you're looking or what you're doing exactly. Yeah, 480 events here, right? So you need to parse all these different types and things. It's quite a lot. So I'll keep thinking about how we can pull out the file names as we move forward, but we could consider this pass of getting the thing wired up kind of a success, I think. What I want to do now is just actually upload all of the files to this vector store with that loop. So I'll go over and do that now. Okay, so all we have to do, I think, is this in this create file OpenAI script. We just want to take out this here and save that, and then we want to delete under storage. We want to delete those files that are here. Okay, so now we have no files. Now we'll rerun this script here. Okay, so I just went down a rabbit hole thinking I was missing about 80 files because the length of the links, the list of links that we extracted from that GitHub repo was about 235 links, and I only had 155 files. So we can see over here number of URLs versus number of downloaded files. The problem was that some of these URLs are double listed for different categories. So like they're relevant for different areas of research. So the same link pops up in the GitHub repo more than once. Anyway, now we know we have about 155 files to work with. I'm going to run the upload file loop on this and get that associated with our vector store. So we should just be able to run this. Now note that we have over in our file storage already. It doesn't show us offhand how many files, but I think there's about 40 that got uploaded. And so you might be curious to know if there is a bulk delete feature. And there doesn't appear to be. But what you can do is, again, get a list of your file IDs and just write a loop to delete all the files. Again, it might be handy to have a convenience method here to delete a whole bunch of files. Let's say delete all of my files in my account, for example. Of course, that might be dangerous, so you might not want that. But here, I think I'm going to have to write another loop to do this. So what I'm going to do is just give the curl command for delete file and list files to ChatGPT and say, write me basically a convenience method that deletes all of my files. So here's the delete file. We'll copy this. Say I want a method to delete all files from OpenAI API. Here's curl for delete. Here's curl for list files. And so this will give it this sort of API context. I guess we could use the Python SDK. That makes more sense because we installed it after all. So if we switch this to Python, we see it's quite simple actually. So let's do this. Let's take all the files documentation and just paste it into ChatGPT. It'll be easier, I think, because then it'll get the context for what's coming back and so forth. So we can say from here down, I think this will work. It's a little bit heavy-handed maybe, but that's okay. And then here I think is the end. Copy that. Here are the docs. And then delete all this and just paste it here. Oh, and in this request, I didn't paste I just pasted the docs. I guess it didn't bring over the code, like the code blocks in here. It's still set to curl. So just made a little discovery, which is that if you change the language here, say to Python, all of the other ones will change to Python too, which is great. But if you're using this to navigate around, which I was, you can see up here we have this query parameter lang equals Python. If I click files to go back to the top of files, we lose that language. So just bear that in mind if you're using this to feed your prompts, as it were. Okay, so we'll copy all of this context and try again. And it should just have a couple of simple calls like list files. Should give us all of our files like that, file.list, I guess. So it's actually giving us the wrong code, it looks like. It's saying OpenAI.file.list, which is not the right method. It's files.list, but we should still probably be able to take this as a skeleton. We'll create a new file here, which is delete all files. We'll paste it in here, and we said it was OpenAI.files.list. So if we run this, we can just do this. Before we try deleting anything, we could comment all this out, run our terminal here again. Okay, I forgot to provide our API key again here. We're using a different pattern. I didn't even notice this. So we probably just want to stay with the same pattern here. So I'll just copy this, right? And this is files ends up being client.files.list. So I guess both patterns are probably fine. So the other pattern we're using here is, it's a named import. They're saying from this package, import this object. And so that's the client object that we're instantiating. So we'd say from OpenAI, import OpenAI. And so now this should work. Now note the other way that you can do this, if you're in production, you shouldn't be coding your API keys into your code. So what you would do here is you would say export an environment variable. So OpenAI API key equals, if you paste your key like that and then run your code, it should work. So it says object is not subscriptable. We ran into this before. That's fine. That's just not indexing like a dictionary, but like an object. Here we go, files.data again. So I guess one takeaway here is that ChatGPT can be great for writing code, but it doesn't always get it right. And there's all the files, great. So here are the files in the account, or in this project rather. Now if we uncomment these lines, presumably, we have to change this to client and run it again, then we should end up with no more files. That has to be lowercase, I think. We can double check client.files.delete like this. All right, and then we'll try this. File deleted object is not subscriptable. So same thing here. Maybe comment those out for the moment and see what happens here. File deleted. So there's an ID, there's a deleted parameter, and an object. So I guess if we change this to .deleted, we could say if response .deleted, then do this, otherwise don't. Say fail to delete, but anyway, that doesn't seem all that necessary. It's just sort of niceties for the terminal UI. So if we come back to here, I'm going to close one of these. We come to files, we should have now no files. So that's good. So now we've got no files, but we still have our vector store. We could modify this to say user modeling docs, or instead of doing that, we could set up on our page, we could set up a workflow that says change name of vector store. So we'll say change name of vector store. We'll say input vector store name, and then we'll just have another button. We'll say change vector store name. And then here you want to say modify vector store. And the vector store ID, we can just grab from over here. Paste it in there, leave this blank, leave all of this blank, and change the name to user modeling VS for vector store. Now, if we reload this page, click on that button. I suppose I didn't use that input that I put there, but that's okay. We'll click this and then come back to our storage. If we reload this, yeah, user modeling VS, no files attached. So what we're going to do now is run this upload script for all of the files. So that's the create files OpenAI. And now you can see it's uploading each file with file IDs. All right, and we can see we're getting lots of files here, which is good. So this is populating our library for our assistant. Once this is finished running, we'll either be able to get our file IDs from this file, although it may not be working because I opened the file in the wrong spot. If not, we can just grab all the file IDs using list files, and we'll stick those in this vector store. We probably have finished uploading our files. If we come back here, it looks like they are. So the next thing to do will be to put all those files in the vector store, and then we're effectively done this first pass. So let's do that now. Let's connect those files to that vector store. So if we come back to our storage, we should be able to load files forever, effectively. Well, not forever, but for a while. So now what we want to do is attach that list of files to this vector store. So if we come back to our API reference, vector store files, as we mentioned in the beginning, this sort of abstraction between files and vector stores, we want to here create vector store file. So it says create a vector store file by attaching a file, which we've just uploaded a bunch of, to our vector store. So what we probably want to do here is get a list of all our file IDs and then create a vector store file for each one for this particular vector store. So we can just do the same thing we've done with the code block before and probably have to modify it. But we'll set this to Python and we'll copy all of this documentation about vector store files, which is what we're currently operating on. And we'll come over to ChatGPT and we'll say, I want to attach all my files to vector store. We'll fill this in a minute. So here are the docs from OpenAI. Paste those in there. We don't really need this here. We can change it in the code. So we'll paste this in and see what little code block it gives us here. Of course, we could just reference the documentation, but that's slow. So let's not do that. Okay, so we'll copy this code. We will come here and create another convenience file, add files to vector store. And here we go. So we probably want to do the same client pattern again. We need our vector store ID, which would be here. And then, okay, so this will be client.files.list. This will be files.data. And then here we will say same thing here, file.id. This here, we have to double check. The method is client.beta.vector.stores.files.create. So this replaces this. Hopefully that works. So let's try running this. Oh, and we forgot our named import. So from OpenAI import OpenAI. And we can see here it's attaching the file. So assuming this proceeds through all 150 files, we should have our assistant up and running, referencing all this literature that we've collected, and it should be helpful. Now there's probably some time to upload the files, chunk them, index them, and then attach them to that vector store. So I'm going to wait until all of the files are uploaded, and I'm going to break the video here and come back in a few minutes, or maybe tomorrow, and look at the difference between an assistant that has had all these documents uploaded to a vector store and one that hasn't, just to see the difference in quality. Because testing before attaching these files to the vector store, it was clear that it didn't have the specific information from these papers that we would want it to have access to. So it'll be cool to see the difference when everything is available to it. So we'll pick that up in the next part.